Mechanical energy is a form of energy due to an object's velocity and position. We've talked about two different forms of mechanical energy. We've talked about kinetic energy and potential energy. Both of these are variations of mechanical energy. Or another way of looking at it is if you take the total kinetic energy of an object and add it to the total potential energy of an object, you get its total mechanical energy. Think about what happens when you hammer a nail into a piece of wood. The hammer has mechanical energy due to its position and velocity. When the hammer strikes the nail, it transfers that energy into the nail, and the nail moves into the wood. If you've ever done a lot of nailing of nails or screwing of screws into wood, then you may have noticed that they actually heat up as you work. So if something's heating up, then that means energy must be involved. So if we just have kinetic and potential energy transformations of between these two types and transfer from one object to another, where's this heat coming from? Well, let's look at it in the case of a bouncing ball. In this image showing a bouncing ball is the mechanical energy from the ball's position and velocity conserved. If not, what happened to the energy? Well, we know that energy is conserved. Okay, that is a law. Okay, energy is conserved. But is mechanical energy conserved? And the answer is no. Some of it changes into non-mechanical energy. Here we see a bouncing ball, the same bouncing ball. Let's graph its energy. Let's say before it starts bouncing, when it's first held up in the air, before it's dropped, it has all kinetic energy. Let's say it has, what is this? 1, 2, 3, 4, 5, 6, 7 units of potential energy. And then it's dropped from whatever height it's dropped from. And right before it hits the ground, for its first bounce, it now all of that potential energy has changed into kinetic energy. So now it has 7 units of kinetic energy, no potential energy. Now, when it hits the ground during the bounce, what happens to the ball? During the bounce, okay, so during the bounce, that um, some of that kinetic energy changes into a little bit of elastic potential energy, which is what makes it bounce back up, right? So you have a little bit of elastic potential energy. But let's not worry about that. So, well, sure, let's worry about that. So it's not moving so much at the bottom. So when it squishes down, and when it's completely squished down, when it stops moving before it bounces back up, it doesn't have any kinetic energy, does it? No. So it has mostly potential energy before it bounces back up. But why didn't I draw the potential energy all the way to the top? Why not, where's that other 1 unit of energy? Well, it takes a certain amount of energy to deform the ball, to squish it. And that squishing is reflected in the internal energy of the ball. I drew it in yellow. I don't know if it shows up very well, so I'm going to redraw it in orange. Okay, so there's the potential energy of the ball. Notice the total energy is still 7 units, but some of it now is in internal energy, or what might be reflected as an increase in temperature. So then that's when the ball is stopped, it's squished, and then it expands and it shoots back up in the air. And now when it bounces back up in the air, it's still, that internal energy is still there, but now all of that elastic potential energy from the squishing of the ball turns back into kinetic energy. So, but now we only have 6 units of kinetic energy, because one of those units has become internal energy, and that's why That's why the ball doesn't bounce up quite as high as it did before. And with each bounce, it gets a little bit lower, and gradually, we get to this point where we have, and I'm just going to draw this by hand because I didn't make enough, uh, I didn't make enough graphs for myself. So gradually, we get to this point where we have where the uh, where the ball is going to stop bouncing. And what does that mean when it stops bouncing? That means it has all internal energy, all of that kinetic energy and potential energy. And I apologize for not being consistent with the colors here, but all of that kinetic energy and potential energy has now been converted to internal energy, and the ball stops bouncing.